Hello, we're going to start another chapter. So this one is going to be dealing with vibration and waves, and these are the topics we're going to cover. Simple harmonic motion, wave phenomena, wave characteristics, wave motion, and interactions. And this is all kind of introductory stuff. We'll touch on things we covered in chemistry last year, and we'll add some new things. So we're going to start with simple harmonic motion. And here are some vocabulary, and this will also be up on the board. So we've got simple harmonic motion, which is just periodic. And if you think about a spring going back and forth, depending on where it is, it's going to have different unbalanced forces, and we'll talk about that more specifically as we go through. The period is the time needed to complete a cycle, and we talked about that a little bit with one of the problems we did when we were doing circular motion. Amplitude is going to be the distance from the equilibrium point to the point of greatest displacement, and it usually is going to be even in both directions, positive or negative. And then we have the frequency, which is just the number of vibrations per unit time, and we measure that in hertz. The first law we're going to talk about is Hooke's law, and it's going to be a spring force. For small displacements, the spring force is proportional to the displacement, and the period is inversely related to the frequency, and so there's the formulas for it. If you remember, K looks kind of familiar. We've used K before as a spring constant, and so you know that the spring is always going to go opposite where the weight is, and so that's why that negative sign is there. Here's a problem we could try, and so we are going to go ahead and work our way through it. We know that our mass is equal to 0.55 kilograms. We know that it's attached to a spring and it's displaced, so there's our X value, 2 centimeters, but we know we're going to need it in meters, so we're going to go ahead and convert it to 2 meters. And they ask us what the spring constant is. They want us to solve for K, but they really don't explicitly give us the force that is going to be needed as well. So we're going to have to figure out how to do that first before we do anything else. So if you think about a spring, the only thing that's acting on it in a downward direction is going to be weight. So we're going to be able to say, well, the force due to gravity, or its weight, is going to be its mass times gravity, and we know gravity is in a negative direction, 0.55 kilograms. That erased my dot. Times negative 9.81 meters per second squared, and that is going to give me negative 5.40 newtons. Well, I know that that is what is acting here, so we can make those equivalent. So now I have enough that I can start and put that negative 5.40 newtons is equal to the negative spring constant times the distance that it's been stretched, which is my X. So negative K 0.020 meters. So I'm going to have negative 5.40 newtons is equal to negative K 0.020 meters. And if I solve for K, I will now get 270 Newton meters. Newton divided by meters this time. Newtons per meter. And that is our answer. So using the things that we know, we can actually work our way pretty easily through this information. Okay, here's 2 problems in the book that you can practice on your own and see how they work out. We could talk about them in class, so go ahead and try those. And that would be a real good place to start for a quiz, possibly tomorrow, but go ahead and look at those. And that's going to bring us to this idea again of simple harmonic motion. We can talk about stretched springs. which is energy is going to be converted between the elastic internal energy. Remember, we used U in last unit, and the potential energy, nope, the kinetic energy. And in pendulums, the energy is going to be converted between the gravitational internal energy and the kinetic energy. So those are the things that we're going to be thinking about. So try those problems out of the book. We'll talk about it tomorrow, do some more practice problems, and then we'll move on to pendulums. So good luck.